off with, I really want this to kind of be more of an informal thing, Q&A and workshop style, but at the same time, I have a lot of stuff to get through here, so I don't know how much time we'll be able to dedicate to workshop stuff. We'll see how we go, but especially with the JavaScript prototype stuff as we get into that. And recognizing that, everyone's at different levels with JavaScript. Some people are, beginners. Some people already basically know everything here. So we're just going to go from, the very basics and try to bring everyone up to the same level of understanding. So feel free to ask questions as we go along, and we will do a little bit of kind of workshop stuff, let people play around in their Node console. So by the way, is anybody having trouble getting the Node console, getting Node.js set up and opening the console? Or is everybody good to go? All good? All right, cool. To start off with JavaScript, it's important to understand that almost everything is an object. So that includes functions. Arrays themselves are objects. Basically everything except for a few primitive types. You have basically strings, numbers, booleans, null, and undefined. Those are not objects. However,
null is actually an object. And strings have weird. So
what's that? Objects. No. Strings are not objects. That's the thing. So I'll show you something. Check this out.
They don't inherit from the object prototype?
No. So watch this. Okay, so we have a string. Now, strings do an interesting thing because there are object wrappers that you might be familiar with the concept, like from Java or whatever else. So for example, you can say, I don't know, string dot, I don't know, substring, right? So you can call functions on a string and kind of treat it like an object, right? But you'll notice, for example, if you take that same string, try to assign a property. It doesn't exist because the string isn't actually an object. What it's doing is it's borrowing those functions from the string object, because there is a string object. So you can say new string, str. That gives you an actual string object, right? But the primitive string type, it essentially gets wrapped by that. But the primitive types do borrow methods, and we'll talk more about borrowing as we get into this, but they do borrow methods from their wrapper objects. So that's why it might look like an object, but it's actually not. As we see, you can't assign, a property to it because it's not actually an object. Okay.
Instantiate the string, can you assign stuff to it?
If you want to assign stuff to it, you have to create the wrapper object. So you'd say equals new string or test, whatever, something like that, right? And then you can say str.test equals hi, right? And then now it exists because it's actually an object. It's a wrapper object that inside of it contains the primitive string, but it also contains all the methods, and it is actually an object. But when you dump out str, you'll notice it's an object, unlike if you were looking at that, which is not an object.
Function is an object.
Yes, function is an object. When you look at that, function itself is actually an object, and we'll get more into instance of here in a sec. But just so you can see, for example, if you say something like function, right, and then you can say you only do this with objects. But what did I do wrong? Oh yeah, why did I do that? Instance of function, right? So you can see. Yeah, that's true. That's interesting. Anyway, for all intents and purposes, you can't assign properties to null and things like that. But yes, and there is a difference between null and undefined. Although you're probably all aware of that. Anyway, but aside from that limited list, really everything is an object and can be treated like one. Okay, so we're going to dive into objects here a little bit. We're going to play with objects because, one thing I noticed a lot online, a lot of things start off trying to explain prototypes with constructors and functions, but I think that makes it more confusing, and it's already a kind of tricky topic, a tricky thing to understand. So we're going to look at prototypes in a different way, and hopefully it'll make sense. But we're going to try to understand how JavaScript works. So let's say we create an object, right? So O is an object. Now, objects have a prototype that they inherit from, and I'll explain more about what that is in a second. But objects have two things. Every object gets created from a constructor, right? So you can say O.constructor is a function. It just so happens that when you create a plain JavaScript object like that, or no, not that.
Justin,
What?
Glenn's saying he's on the call with several other people, but he can't see anything.
No, that's not going to be helpful. Pop that up.
Your screen is sharing.
I'm sharing my entire screen. Oh, maybe I need that. There we go. Can you see it now? Okay, apparently I didn't do that. All right. Anyway, so objects have constructors, and objects have, now this here is an internal property. You can't change it. You can't write to it, but it's useful to have around, at least for the sake of understanding, right? So objects have a prototype. It's a separate object, but it kind of inherits from this prototype or through this chain. So, and functions, so let's go ahead and say function fn, right? This function has a prototype property. You don't want to confuse these two. So the prototype property of a function really has nothing to do with the function itself. It has everything to do with what happens when you use that function as a constructor to create a new object. So that gets into the next thing. In JavaScript, every function is a constructor. So I have this function I can call, right? And of course, it doesn't really do anything. But what if I do something like new? I use the new keyword. Now it returns an object. It just created a new object, an instance, essentially, of that function. And that's where that fn.prototype comes into play up here, because that prototype, so if I say O equals new fn, and then, what? I did really well here. Okay, so I say O equals new fn, then I say O.proto equal to fn.prototype. It's the exact same object. So that prototype object got set as the proto property of the object that was constructed from that function. But that can't be changed. Once you create an object, you can't change its prototype chain. That's set in stone. Okay, so now we have this object that's an instance of fn here. So let's go ahead and assign a property to the prototype. So let's say fn.prototype.prop1 equals test, something like that, right? Now, if I look at O, you'll notice it doesn't have any direct properties on it. But what if I say O.prop1? It exists, right? So what happened here is it first looked at O, said there's nothing there. Then it went to O.proto, and it said, the property exists, okay? So the way prototypal inheritance works, you're basically creating a chain of these prototype objects. So if we want something that now inherits from fn, let's go ahead and create a function. We'll call it, I don't know. I'll be really creative here and say fn2. Okay, so we just created a new function constructor, right? But if we create a new instance of that, it has nothing to do with the original one. What we have to do now is we want the prototype property of fn2, because that's what's going to be assigned. So fn2.prototype, that's what's going to be assigned to anything that we create when we say new fn2, right? that prototype property. So we want that prototype property to somehow be linked to the original one, fn, right? So let's go ahead and say fn2.prototype equals new fn. Okay, so if you think about what just happened there, it created a new object that has a prototype that is fn.prototype, right? But if we say fn2.prototype, that's what we're looking at. And then if you look at the proto of that, it's the same thing, right? So we just created this chain. So now if I say O2 equals new fn2, now we can say O2 is a plain object, O2.proto, plain object, but you can see its prototype is equal to fn2.prototype, right? And then if you say O2.proto.proto, now we have a chain that goes all the way back to the original one that we created. Is this kind of making sense? Are there
I'm
questions?
still confused what the underscore proto and prototype, what the difference is.
Okay, so basically all it is when you create a function, right? My fn, where am I doing var? You create a function, and then you say dot prototype dot something equals some of that, right? So that function has a prototype property. All functions do, and we just added something so just so you can see it's not an empty object. Now, anytime you create an object from that function, so you say my object equals new my fn, so use the new keyword to construct a new object. And when you do that, that object that just created has a proto property, that is my fn.prototype. They're the exact same object. So it takes the prototype property of the function and it assigns that as the actual internal prototype of the object it created. Does that make sense?
Mhm.
Okay, so that's really all it is.
And when you access a property, how does it go through prototype and underscore proto? Does it check prototype first and then go to
The first thing it's going to do is look directly at the object itself, see if it has the property. If it doesn't, then it's going to look at that object's proto, right? And if that doesn't have the property you're looking for, it'll continue to do the exact same thing all the way up until it gets to null.
So the object itself has the proto, but the function has a property called prototype.
Yes. And the prototype property of a function only matters when you're using that function as a constructor to create a new instance of an object or instance of that function, essentially. You're creating a new instance, you're creating a new object, and at the time that you create a new object using the new keyword, it takes the prototype property, whatever it happens to be at that time, and it assigns it as the proto of the object that's created.
So
That's
underscore proto is what's inherited from somewhere else, but prototype is what's introduced on that class.
okay. Yeah. So the thing you don't want to confuse here is, so prototype is, you know, the prototype keyword there exists on functions, not on objects. You can't say my object, right? It's an object dot prototype. That doesn't exist. Functions have prototypes, objects don't. Functions have a prototype property, objects don't. But objects have a prototype.
The prototype becomes the prototype.
Not to be confused with the prototype property of a function.
The function has an underscore proto property too, right?
Yes, because a function is an object, but that's a separate thing. You can ignore that for all intents and purposes. Don't worry about the proto of the function. Yeah, just
Tell us why we're worried about this.
yeah. So this is this is all about inheritance. That's what it comes down to, because it's still important to be able to create instances of things and inherit. So before I talked about instance of as well. So let's say, for example, we have, maybe we should start from scratch so that it's not confusing. Okay, so let's say we say function, we're going to create a constructor and we'll call it car, okay? We have a car object. And then now we're going to create a function and we'll call this one Honda. And then we're going to say Honda dot prototype equals new car. Okay, so now Honda is a child of car. So if I say var, I don't know, my car equals new Honda, then I can say my car instance of Honda, and it's true. I can also say instance of car, and it's true. Okay, it's important to understand what the instance of property is doing there. What it's doing is it's saying, it looks at the constructor function you pass in, it'll look at its prototype property, and it says, is that prototype object anywhere in the prototype chain of this object? That's what it's really asking when you say instance of. So if I now go and take car, and I say car.prototype equals, and then we create a new object. Now if I say my car instance of car, it's false. If I wanted to fix that, of course, I could then just say car.prototype equals my car.proto. Did I do that right? No, dot proto. There we go. And then instance of car is true again. So it's looking for just the prototype property of the function and asking, does that prototype object exist in the prototype chain of the object you're looking at?
There's one thing that's really helpful for like in PHP when you create a class, and you say, this property, like, example equals an array. Every time you create a new class, it creates a new array. In JavaScript, because it's referring to literally that object, and if you did the exact same JavaScript, that array would be shared across all instances of that class.
Right.
And so that's for kind of understanding that you have your prototype is literally pointing to that's an object that is shared. So when you type a new thing, it doesn't go and make a copy of it. It's literally pointing to that prototype.
Although
Right.
it can get complicated because you can shadow over
Yeah.
parameters like strings and things like that.
Yes, you can do a lot of crazy stuff with JavaScript that you probably shouldn't, but it's pretty flexible. I mean, it won't stop you from messing with any of the internals either. So you can do a lot of interesting stuff. Anyway, so this is important because when you're programming in JavaScript, you often use some form of inheritance or assignment, when you're creating a new type. So if I wanted to create a new something that's kind of the equivalent of your object-oriented class, I would say, I'd say function something, right? And I'm going to say something dot prototype dot method one equals function console.log, do something, whatever, right? So I create that. Now, when I create an instance of that something, I'll say equals new something, and then I say thing dot method one, and it calls that. And so I can create different instances of something now, and they're completely separate. So when you use the new keyword, there's also a this context, which we'll talk about later. So the context of this really is only applicable, in treating it like an object when you use the new keyword to call the function. Anyway, so now that's kind of the most vanilla way to add methods to a to a new type, a new object or whatever, a new class essentially. There's something that you'll see a lot in code. There's a new thing, well, newish. Actually, it's pretty new because it's only supported in Firefox right now. But you can, if you have the shim for it, you can then instead say object dot assign something dot prototype, and then you can pass in an object, with method one, etc. Right? So, assign, yeah, assign. Anyway, now I can't call it here because it's not supported by this engine, but it's a newer ES6 feature. There's equivalent shims and things out there that provide the same functionality. All it does is copy all the methods from this object here over to this object. So it just copies the properties over, and it's another way of kind of a cleaner way of being able to assign methods or properties to an object when you're creating a new type.
Change your color scheme. It's really hard to read that up.
Is it? Let's see what we can do about the color scheme real quick. It's under, I think it's under profile.
Work on white.
I want to do black on white.
Yeah.
Oof, it's a sin. Okay.
Every day.
All right. Okay, so prototype is just important to understand, because if you want to be able to create multiple different objects that have shared properties, that's how you share properties between instances. So I've got I created this thing, right? It's an object, and it has this method on it, right? But what if I create thing 2? Right? Thing 2 is a different object, right? Thing 2. If I can do that, they're not the same object. But thing.prototype, or not prototype, dot proto is shared between the two. So you can see they're sharing the same prototype object, which means if I say that function now, dot prototype dot something like that, right? I created a key. So now if I say thing dot key, it exists, and thing 2 dot key also exists. So because they're sharing the same parent object, they inherit the same keys, and we can share those between them while they're still different instances of an object.
What if you tried to set key on thing, would it change on thing?
Set key on thing? No. See, if you say thing dot key, this is also an interesting case. So you can say something else, right? So now if you look at thing, it actually has its own key property. It's not coming from the parent. So if I say thing dot key, it's that. But if I say thing 2 dot key, it's still the parent one. It's just inherited. Okay. Now if I say, this is another important thing to know actually, if I delete thing dot key, do you think that thing dot key has no value now? We just deleted on the local object. So if I look at thing dot key, it's still inherited from the parent. Yeah, so instead you have to say thing dot key equals, you can say undefined or null, something like that. And that's a whole different thing. So
But then also if you had an array on the prototype and then you said thing dot array equals, you would actually transfer those. Try again.
oh yeah, well,
Change the internal.
yes, because
arrays and objects, because they're
because it's by reference, exactly.
If you change the prototype at runtime, then you're affecting all instances that are out there at the time.
and all future ones.
Well, yeah, if you make changes to the prototype, yes, that will be carried through to all of them. So yeah. Anyway, so you guys are welcome to open up a console and play with this. I feel like that's probably the best way to solidify it for people that don't understand. Do you guys want a few minutes to just play around and ask questions if you're not understanding something? It would be nice if you could try to create an object and then create a child object, and just see that it inherited, essentially, that you can do child instance of, and then parent, and that comes through. If you want to cheat, I can put it up here, but yeah, let me say what am I saying? Yeah, prototype equals new parent. Okay, so by doing that, now if I say new child, just to nice and clear, then child instance of child, not child, I keep capitalizing it, and instance of parent. So if you can essentially get that far and understand how that's working, then you have a decent understanding of prototypes. Now there's some trickier stuff because you don't actually want to do something exactly like that when you're actually inheriting. Because on this line that's doing new child, so that you know when you say new child, it's also calling this constructor function. Now there are times you want to inherit, or sorry, new parent, that's the one I was referring to. It's calling this constructor function. Now there are times you want to inherit from parent without calling its constructor function, which is most of the time. So there's another trick to doing that, and there's helper functions, so you don't actually necessarily have to worry about well, it depends. There's helper functions in Node.js, but in the browser there isn't. So maybe I'll go ahead and show you if, yeah, okay. So if you want to do that, what you have to do essentially is create a temporary constructor that it's a do nothing constructor, right? Then you have to take that temporary constructor, set its prototype to be the same thing as the one you want to inherit from, parent.prototype. Now they share the exact same parent object, and that prototype property, remember, that's what's actually being set in the prototype chain when you create a new object. So now if I say var child object equals new temp constructor, then it essentially inherits from parent without actually calling the parent constructor. So now I can still say child instance of parent, and remember, because parent, it looks at parent's prototype, and it looks for that prototype object in the child object's prototype chain, and so it's still an instance of parent, even though we didn't actually call the parent constructor. We used a temporary constructor that shared the same prototype. So that's how you really need to do inheritance, in the real world. Like if you're doing this in a browser without any helper functions for inheritance. But anyway, yeah, so I'll give you a couple minutes.
Wait, you're arguing that in production we want to assign .prototype directly instead of doing like object.create?
Oh, well, I haven't gotten into object.create or any of the others. Yeah, like I said, there's a lot of functions that are out there, things that help with all of this. But it's important to understand, for the sake of understanding how prototype works. Essentially, this is it.
That's fair. It's just when you said this is what you actually want to do.
No, like in Node, you can actually use something called util.inherit. Yeah, exactly. Yeah, and then you can pass instead. You could say child, and then you'd say parent, and that'll set up the inheritance without calling the constructor. You can create an instance of it. But in the browser, you don't have that. However, in any reasonably modern browser, you do have object.create.
Of course, that's slower.
That's true. That's true.
Is it?
Yeah.
Significantly slower.
Yeah. It's not really that hard. Once you understand how prototype works, it's not actually that hard. It's just understanding every object has a prototype chain, and it's, the prototype of the constructor function that really matters. Did you have a question?
Yeah, I'm wondering why you can't just assign the prototype of one object to another object.
Well,
Instead of
okay, the thing is, even though we have access to C, what do we got? So child dot proto, right? That there is what the browser is actually following, that proto object. That's what the browser keeps internally to follow the prototype chain, and you can't write to that. You can't set that property. You can't change the prototype chain. It's locked in once you create a new instance of an object.
So that's
technically that's kind of deprecated. It's not really. It's a thing that many browsers have exposed, but not something you can really edit. And it's it's helpful for instructional purposes, but you can't really change the prototype of an object once you create it.
Underscore proto is created when you do
That's created using the new keyword. Yeah. So you have to use the new keyword to create it to get the proper inheritance with the prototype chain. You have to use the new keyword.
All right, let's keep going.
Okay. Are there any other questions?
Is there anything else to JavaScript, or is this
No, that's it. That's JavaScript. No, there's tons here. But that there is one of the, I think one of the most important concepts to understand. Otherwise, you end up with weird bugs you'll spend hours on and you won't understand what's going on. It's really critical to understand how prototype works. It's not a traditional object-oriented programming language, basically. And it's not incredibly difficult, I think, especially once you spend any time in it. It just, it's something that you got to understand. It's a foundational principle. Okay, so I think we've covered all. Oh, one other interesting thing worth noting, I think. I mean, we use this with Dash. It's the only way we're able to do with a lot of what we do. But if you have a function, you return something, you return an object, right, from the function. And then I say, so I can call that, of course, and it's going to, gosh, I can type today. So it returns that object. But what happens if we call new on this? It's returning an object, right? So I say var new object equals and that also equals the returned. So it essentially throws away the function that was, or the object that was initially constructed, and it returns what you returned from the function instead if your constructor returns an object. It's actually helpful for using the singleton pattern, creating singleton instances of objects. You can return from your constructor, and whatever you return, as long as it's an object. You can't return a primitive value. That will be ignored, and it will use the created object instead. But you can return an object. So anyway, all right. We'll move on. Okay, we kind of talked about all this, but it is important to know that when you're looking up a property on an object, it is following that prototype chain, looking in the object itself, then it's proto, and then that object's proto till it finds null. And so if you're looking for a property that doesn't exist, you try to reference a property on an object that doesn't exist and it has a long prototype chain, it's going to have a performance impact potentially in a critical section of code because it takes more time to follow that prototype chain and keep looking till it finds the property. So it's always good to be aware of that so you can avoid looking for properties that don't exist if you don't have to, or find other ways around it, especially in critical sections of code. Okay, this is another thing that needs to be mentioned. It's important to understand there are two, well, and this kind of gets into this context, so maybe I'll hold off on that for a second, actually. Just to understand exactly what's happening when you call or when you use the new keyword, it actually creates a new object. It sets the object constructor to the function called with new, and then it sets the it calls the constructor, taking that object, setting that as the this context for the function as it's running, and then it returns the new object. Okay, I'm actually going to talk about this context first. So I'm over here. Sorry, I was doing this a little bit late last night. I didn't necessarily get the order the best here. But okay, so the concept of what this means inside of a function is actually very ambiguous. It can be set dynamically. So let's go ahead. I created a bunch of examples. Trying to figure out what's going to be best to show here. Is that hard to see? I'm not really sure. Let's see. I never changed my color scheme here. What is it? I don't even remember where the color scheme is. Well, what I'll do is I can just copy some of this out to the console. It's easier to see when I highlight it, maybe. Okay, so let's say I go ahead and create an object that looks like that, right? So it has this property, sumVar, and then we created a function on there, a function property that will console.log this.sumVar. What do you think this is in the context when you're calling that? The important thing to understand here is it's all about how you call it. It has nothing to do with that declaration. You can't tell what this is going to be. right there. You have no idea. So let's say I say obj1.fn1, right? Then what's the this context going to be? It's going to be that object, right? So let's go ahead and say I create a new object. We'll say var obj2 equals new or equals just an object like that, right? And then let's say I go object2 dot fn1 equals object1 dot fn1. Okay, now what's going to happen if I say you know object1 dot fn1, it still works. Now what if I say 2 dot fn1? By the way, that's called borrowing. We just borrowed that function from this other object. Oh, fn1, sorry. Right, it's undefined because that. Remember, I probably should have. Anyway, remember what that was doing was it was looking at this dot sum var, right? So what if I say obj2 dot sum var equals u2, something like that, right? Then I call obj2 dot fn1, and all of a sudden it exists, right? So the context of what this means is completely dynamic based on how you call the function. So there's a few different ways you can call things. And this is where I want to talk a little bit about call and apply, because you can actually set the context. So let's say I go object1.fn1.call, and then I say sum var is set to another value. So now we've just called it. We've passed in an object that's going to be what this means when that function is called. We've passed in an object, and that is the context. The same goes for the apply function. Now, the difference between call and apply, this is an important thing to understand. Call, if you want to pass arguments to the function. So let's say we define a function arg1, arg2, right? And then we're going to console.log arg1, arg2. So this is the difference between call and apply. If I say myfn.call say thing1 and thing2, you'll notice that it's able to log them out. So I passed the arguments as just normal parameters, but there are times that you need to there are times that you have an array of arguments you want to pass into a function, and when you have them as an array, that's where apply is useful. So if I say apply, if I can spell today, if I say apply, and then we make that array, we see the same thing happens.
So the use case for using call or apply, is that typically just for if you need to change the context of this? Or is it just calling the function as you normally would?
Pretty much. Apply is also useful when you do have a dynamic set of arguments in an array that you need to pass in. So there are a number of different uses you run across. But let's say, so it's useful for changing, I'm trying to think of a good example with an array. One reason that you might want to do that, for example, so we're going to borrow a function here. So let me preface this by saying inside of a function, console.log, there's a special variable called arguments, right? And that's going to be an object, not an array. It kind of acts like an array, but it's actually an object that contains the arguments that you pass in, right? So you can see that that contains the arguments that were passed into the function. But let's say you need to pass those arguments through, or maybe modify them and pass them through to another function. So if you need to do that, then you can't call apply with an object. That's just going to throw an error. You have to apply an array. So the way that you do that is you could say, I don't want to create some recursive there. So this will do a console.log arguments. Then we'll come back up here, and instead of logging those out, when we call myfn, we're going to say fn2.apply, And then you can say this. We don't care what this context was. We're just going to proxy it through, basically. And then instead of saying arguments, because you can't apply arguments as an object if you want the parameters to apply, we're going to borrow a function from the array prototype that can. So you say array.prototype.slice.call arguments. And now, if I call my fn, oh yeah, because I didn't pass anything through, arg1 and arg2. There we go. So you can see they essentially got proxied through, and we were able to apply that array. We don't know what arguments were passed through. That could have been any variable number of arguments. We just know that we proxied those through. And the way to do that is to apply whatever arguments happen to be given. So this is the thing you'll often see in JavaScript, is borrowing the slice function from array and passing arguments in. Now in this case, you'll notice that arguments is being passed in as this context. So it's like an array. If you have an array, 1, 2, 3, right, and you say dot slice, we could say slice 1, and that'll give us 2 elements of the array. Or if you just say slice, it's going to copy the array essentially. So what we did was we borrowed this slice function and we set the arguments object as essentially this part of it, the context of this when slice is being called. So then it iterates over those and ends up returning an array. But that's how you can, so this here is actually something you'll frequently see, is borrowing the slice method of array. That's just one example. I've found countless use cases over the years. So, but it's really handy to know. And just know that call will call with what you pass in. You just pass in a list of arguments, not an array. Apply actually applies an array of arguments. That's the only difference. Other than that, they both take this context. Yeah, okay. I will cover one more function here. This is important to know because sometimes you want to essentially bind a certain object to be this context for a function call. So if I say function myfn, and then we'll say console.log this. Now, if I just call myfn, of course, it's our global object. It doesn't actually, it's not anything. If I create an object, and then we'll say fn1 equals, not equals, myfn, we set it in there, and then we say object.myfn. Now it's going to return that object that we called them. Oh, gosh. Okay, anyway, it'll return the object that we called it on. But what we can do instead is say object.fn1 equals, and then you can say myfn.bind, and you can bind it to object there. So what that does, essentially, it returns a function that wraps that and binds the context. So even if I just call that function alone, if I say var fn equals fn1. So we just have this function. I'm calling it with no context, and yet it still has the object context. No matter how I call that function, if I say object2 equals obj.fn1, and then I say object2.fn1, it's still, what did I just do? Oh, whoops, I didn't mean to do that. I meant to say fn1, or I'll call it fn2, just so you can see it's a separate property. So you look at object2, now we've renamed it to fn2. I say object2.fn2, and it still comes back with that original object, fn1. So we've bound that context. So it's always going to be called with a specific context. You can use bind as well for something called currying. So you can say, for example, let's create a function again. It'll say console.log arguments. Actually, instead of doing that, go ahead and say arg1, arg2, and arg3. We'll just make this accept some arguments real quick. Okay. So this is going to log out what we call it with, right? But if I create a let me say read fn equals my fn dot bind, and you can pass null, so whatever this context is will just be proxied through. And then you can say bind arg1 and arg2. So if we call myfn, we can pass, whatever, something like that through, and it's going to call that. But if we call curried fn, we only have to pass one argument through. So let's say I do that. It essentially create a wrapper function that's always going to pass this through as the first argument, this through as the second argument, and this function only takes, it'll take whatever else we pass it and add it to that list when it calls it, but it's adding from here on. So bind is really, really useful for things like that. I've used that, for example, with Elasticsearch. I create an instance of, the Elasticsearch object to communicate with the server, and then I, bind the actual client object. I create a bound function with that instance, so I can, so I don't have to worry about passing the instance through everywhere. I can just make the call and not worry about the instance because it's essentially bound as the first argument to the function I'm calling.
So bind doesn't exist in all browsers, right? It's more
it does actually. It's been around for quite a while. You can use it. Well, let me think. I'm not sure actually about IE.
This was added EMCA's 262 5th edition.
Yeah, okay, so ES5, basically. Any browsers that support that. Yeah, all modern browsers will support that. I don't think you really have to worry about it. It pretty much exists everywhere.
Now, why aren't we maintaining the proper order of arguments there? You found, from the way I look at it, you found the null value to arg1.
No. See, that's the thing. So with bind, with call, with apply, all of that, the very first argument is the context, this context. Right. After that is arguments. That's how they all work. The very first one is just the this context. So because I pass null, it's just going to proxy through whatever the this context is that happens to, that you happen to call it with. Otherwise, you could also bind the context like we showed a minute ago. Now, this one is important to understand because Ryan Florence is going to use this a lot when he does his React.js training. It's really, really useful. So, yeah, it's important to understand. Any questions? Is that confusing? Okay. What am I doing? Okay, I think we're good with all of that. All right. So I want to talk about execution contexts now. How are we doing on time?
30 minutes.
Okay, so quickly we can get through this. So an execution context, it says, is created every time a function is called. So you can think of this here is a good way to represent, at least mentally, what an execution context might look like internally. There's different implementations in the engines. You don't need to worry about that, but just understand this is essentially how you can conceptualize it. Every time you call a function, it sets up this new context that's going to contain basically three things. It's going to contain your scope chain, and we'll talk about that in a second, but that's basically for closures. I think everyone here mostly understands closures, but we'll talk about it a little bit at least. It's going to contain your scope chain, your variable object, which is all the variables that exist, that there's references for in the function, and then your this context. Okay, so yeah, when the execution context is created, the first thing it's going to do is create a variable object by essentially scanning. It first looks at the declared parameters for the function, whatever parameters it says it accepts. Those variables now essentially exist, they're declared. Then it looks through the function and it says, are there any var declarations? And it's going to add those references to the variable object. And then it's also going to look for any function declarations, any named functions at least, and they're also going to exist. Now, technically, anonymous functions will as well, but they don't have a name, so you can't exactly reference them. But that is an important thing I'll mention at the end. Anyway, so it's going to look for all the var declarations, your functions, and your parameters, and all of those are going to be added to this variable object before it even runs a line of code. Then it goes ahead and creates the scope chain And the scope chain is essentially, I mentioned that a little bit here, but a new scope is created for every function. Unlike other languages where you might have block scoping within like a for loop or an if statement or something, variables in JavaScript functions are scoped to the function. The only way to create a new scope is to create a new function. Now, that's not strictly true in ES6 because the let keyword does allow local scoping, but generally speaking, with ES5 and before, the only way to create a new scope is a function, and all variables within a function and at any level, they exist for the whole function. And then, so the scope chain can be thought of as basically an ordered list with that variable object for the local function you're calling that it just set up, all the variables that exist in there, as well as all of the parent execution context. So you look above it. Now, this is a lexical context, which means it has nothing to do with where the function was called from. It has to do with where it is visually in the code. If you look above it and you see in an outer scope, there's a variable that exists, you have access to it from that inner scope, from that inner function. Okay, so anyway, it creates the variable object, it creates the scope chain, and then this context is determined based on how the function was called, and then the function is executed line by line. So this is an important thing to understand, specifically in the case of, let me think. So this is where I wanted to talk a little bit about hoisting. So let's go ahead and look at an example here. I'll copy this out to the console. So if I call this bar function, what do you think is going to be logged out? It's a little bit messy, but it defined a foo variable that's set to 1. Then it says if not foo, it declares foo equals 10, console log foo. So what's going to be logged if I call that function? If I call that, we get 10. This is important because what happens is before a line of code is executed, it goes and it looks for all variable declarations, and those are defined in that variable object. So foo already exists up here. It's just undefined until we get to here, right? So when we say if not foo, well, it's already undefined because it was declared within the function scope. So this is called variable hoisting. Everything is essentially hoisted to the top. To the top of the function for all intents and purposes. So
If you just remove the var.
yes, if you remove the var, then it'll work the way you would expect. But because there's a var declaration, we're not, looking at the existing foo. We're looking at the foo that's declared within the function.
So for clarity, you probably want to make all your variable declarations to the top.
There are people that will do that, and that's an optional linter setting. You can, essentially the linter will restrict it to a single var statement because you can do comma separated. You can do comma separated lists of variables without declaring, right? So you can say foo var as, right? So you can do something like that and declare the variables without ever initializing them. Then you can initialize them later in the function. So some people are very strict about that just because then the code reads essentially the way that the parser is actually going to handle it. So you avoid accidents like that. So it's not a bad practice, but mainly if you're aware of it, at least, then it's easier to track down your bug. Otherwise, you'll be, pounding your head against the wall trying to understand what's going on with your code, why it's not working the way you expect. So just understand that all of those things are hoisted. Now, this is also important. In another context here, let's say we have this code. Oh crap, that didn't help. Let me, gosh, I'm the wrong things here. Put that over. Okay, so that's our code. So if I console.log A, what do you think it's going to be? It's 1. Yeah, okay, so think about what's happening here. B gets called, A already exists, A is declared, but okay, I'm trying to remember. So anyway, A is already declared essentially at the top of the function, though. It already exists. And then, how does that work?
So does that mean the function gets
Oh yeah, that's right. Because of the scope. That's the problem. A is a local variable to the scope. It's the equivalent of declaring var A equals 10 in the scope. So we're not assigning to this A, we're assigning to an inner A. That's what we're doing, because this is the same. When you declare a function, it's the same as like var, essentially, within the scope. It declares a new variable that's added to the variable object. And so we're now dealing with a locally scoped A instead of the globally scoped one.
So basically, var A is a function, and then because you declare A inside the function.
Exactly. So this is only setting the local one, then we return, and then outside of that scope, we're logging A, and that's our.
Could you call A, if you didn't do that return after the A equals 10, could you call A after the function declaration? Or is it going to be 10 by the time you get there?
After the function declaration, you can actually call it, because that's that's essentially like a initializer. It's going to override it. Gosh.
So just the fact that it's declared gets hoisted, not the actual.
Yes, exactly. Declarations are hoisted, not the initialization. The initialization still happens as it's executing the function line by line. So if we were to remove the return, then you could, we could say A, and I didn't do anything. I can just remove that, Anyway, okay, yeah. All right, so that covers hoisting. I covered everything. Yeah. Oh, I was actually going to show an example, though. I don't know if you'll be able to see it with the execution context. If you have this foo variable and you declare A and B, and then you have C here, that this is essentially what your execution context is going to look like before it even runs the function. After running, A gets assigned, B gets assigned, but you'll notice they already exist, and C as well, because it's a function. So they're already declared, they already exist. So that's really all that's important to understand with that. All right. We'll jump over here. Okay, a couple more things that are important to understand. So the way JavaScript does scheduling, intervals, and timers. JavaScript executes in a single thread, so you don't ever actually have any of your code executing in parallel within, no matter what you write. If something ends up blocking because it's really intensive, it's blocking the entire thread. No other stuff is running, even though it's asynchronous. It's concurrent, but it's not parallel. So it has a single thread, and it basically keeps an execution queue, a queue of things that it's going to execute. And as events happen, those events can come like in a browser, mostly from mouse clicks or other types of user interactions, events that happen on the page. When a timer, a set timeout or set interval expires, it reaches its timeout, it's going to add something to that queue to be executed as soon as it gets a chance. Or when you do I/O, you go and read a file, goes and it'll do the I/O asynchronously in like a separate thread. All I/O is asynchronous in JavaScript, or not just asynchronous, but parallel. It happens in a separate thread, but then it comes back and it has to queue up and wait for time from the engine to execute that again. It has to wait its turn in line basically before it will actually call your code that handles the response. So everything happens in a single thread. Now that has implications, because it means that timers and intervals, they're not guaranteed to run exactly on time. So this is important to understand, especially with intervals. Why do I keep going there? I have an example here, and it's this interval one. So what I've done is I've created this interval. It's just going to do a console.log called every 1 second. And then I have this timeout that's going to run, in 1.5 seconds, and it's doing this really big, what is that, like 5 billion loops, just so it is slow enough. It takes a few seconds. And then if I go ahead and run that, let's see, what do I call this again? Data stem on this one. So if I say node interval, now what's going to happen is this here will be essentially triggering, the timer in the background will be triggering every second, right? So do you think it's going to queue up a whole bunch of timers that are suddenly going to fire all off, after it finishes, or what's going to happen? What we see actually happens, it logs the first one, then it's in that loop now doing 5 billion loops. So it takes a few seconds. And then with intervals, this wouldn't be the case with set timeout. If you did a bunch of set timeouts, they would all fire at once, but you'll notice this just continues on with the interval. So if an interval has already fired and it's in that execution queue, it's not going to add another one to the queue. Intervals will only allow one to be queued up at a time. If it's there, if it's there, it just skips it essentially. That's important because sometimes you don't want to add up a whole bunch of work to be done when when your program's overloaded. Okay. And then timers or timeouts are another important thing to understand with set timeout and set interval. They create their own call stack. So in JavaScript, because things are asynchronous, as soon as you give time back to the engine, your code is no longer running. You give time back to the event loop, and then a new piece of code is called. It doesn't maintain any of its former call stack. It's a new fresh call stack from whatever function was queued up for that execution context. It's a fresh call stack. And so you lose that context. If you throw an exception, you do a console.trace or whatever, you try to get a stack trace, your trace will only go up to the function that was queued up to be called, not what actually queued it up. So that's why in JavaScript, exceptions are considered generally you shouldn't be throwing exceptions, you should be passing errors around because you can't catch them if they happen in asynchronous code. You can't catch them and you lose the context. But that's also a useful trick because there are times that you need to queue something up to happen in its own call stack, essentially. It's also a really good way to do deep recursion because there's a maximum amount of recursion before it's going to throw an exception and kill your program on you. And so if you're expecting to do deep recursion, you can wrap each recursive call in a set timeout 0. So it will immediately queue that up to be executed in its own call stack, and then you're not going to get a deep call stack that's going to throw an exception. So it's useful for various things like that, and sometimes you just need to essentially defer something to run until after all the current execution stack has finished running, return to the event loop, and then queue it up to run. That's especially the case, for example, promises will always do that before resolving. Even if you resolve a promise immediately, it's not going to call any any of the resolver functions until after it's at least done the equivalent of a set timeout 0, so it's in its own call stack. So it gives time back to the event loop to do whatever it has to do, but you can guarantee that all of the code, whatever's queued up to run, it's going to execute every line before the promise actually resolves and calls your functions. That is very important. Like in Dash, that's a very, very critical thing. You'll find in a lot of code, it's a critical concept to understand. Okay, let's see if there's anything else. One other thing worth mentioning, if you call clear interval, so in that example I had here, if I were to uncomment this clear interval, that there, by essentially clearing the interval and the timeout right after it finishes this work before we've returned time to the event loop, that will actually completely clear it. So anything that was scheduled in the execution queue for that interval will be cleared and it won't run. So that's useful in some cases. I've had to use that before. Let's see. Yeah, I mentioned all of that. Okay, I mentioned hoisting. The temporal dead zone is mostly an ES6 thing that's important to understand. I don't know if I'll go into that right now. A gotcha that's important to understand though is closures in loops. Okay, so many of you have probably dealt with this before, those that have spent much time in JavaScript, but you should be really careful generally not to define functions inside of for loops, because here's what happens. So let's let's go ahead and pull this out first to console so you can look at it. So what do you think this is going to do? We created this array, then we looped over 5 times, and we said array.push. We create a new function, and each function is going to console.log I, right? So it's capturing I and then adding the function that's going to log it out. So what's going to happen then if we over here and we run this for each loop? That's not exactly what we wanted. We don't get the value of I at each iteration of the loop because it's a static lexical binding. So it captures the variable I, but by the end or by the time we call these functions, the value of I has changed. And it didn't capture the value of I, it captured essentially the reference to I. And so functions in loops can easily cause bugs that will be tricky to track down. Hence, generally, this is a bad practice to avoid. Now, there's a simple way we can solve that. If you really need to do it, go ahead and wrap your you have to actually wrap it inside of another function, essentially. And then you have to say something like var j equals I, and then
You can pass it into the outer function.
so yeah, you can also do that. You combine. Anyway, yeah, that's true. You actually can. If we say this is known as shadowing, but yeah, we'll go ahead and just say I, and then we have a function. We still need that. So this here, and then you have to actually execute. This is the other critical thing. You have to call this function that we just wrapped it. You have to call it immediately in line. So if we run that now, oh, that's good. That doesn't. Oh, yeah. Is that right? Yeah. Yeah. I don't know. Anyway, that's the basic concept. You have to wrap it. What's that? Yeah, there's a lot better ways to do this. You really shouldn't do this. Just don't do it. What I would do instead of doing a for loop at all, the simplest way around this is use a helper, or I mean use a function. So you can say, yeah, exactly. So you could create an array of 1 through 5. You'd have to create the array separately then. Then you can actually, I should probably assign that to something. And you can say a.for each. Now we're creating a function that has its own scope, its own execution context. And this here can actually queue up, a new function. So it could say r.push, whatever. Function console.log I, right? If R existed, which it doesn't, but it could. Anyway, that's the basic concept. Just don't do closures and for loops is the lesson here. Okay, let's see what else we get at. Accidental globals, if you declare a variable, so you're inside of a function and you don't use the var keyword, that variable becomes a global variable. Don't do that. Always use var. That way it's locally scoped to the function. Otherwise you end up with, if you forget to use var, you end up with these accidental globals, and then you can have weird side effects from other things in the code that happen to share the same variable name in another function, and they end up setting a value that you're not expecting, and just weird stuff. So just remember to always use var. And one final thing you just have to be aware of are memory leaks in JavaScript, because you have to remove references to things so the garbage collector can clean it up for long-running apps, which is something you have to worry about in Node. Generally not the browser until you're doing something, a long-running web app like Dash. Then you always have to be thinking about memory and unreferencing things so that you're not storing objects around in memory and crashing their browser or whatever. And one specific one you have to watch out for in Chrome that shouldn't be a problem, but it is because of a current bug in the engine that they haven't prioritized. So an example like this, I'll move this over to the console again so you can see. But something like this, so we're declaring we're declaring this variable here, something, and then inside of our function, which now is closing around this, right? So it's capturing the reference to something. See, garbage collectors are smart. They will, when you create a closure, they're not normally going to actually store a reference to this unless you're using it, unless you're referencing it. But the way that the Chrome V8 engine works, which is what Node is running on, so you have to be aware of this, the way it works is it keeps a single lexical scope for all closures inside your function context. So because even though we're calling if true, this here can never ever run. This closure can never run. Only this one can. But regardless, because there's a closure, this here is at the time before the function even runs a line of code, it's taking these functions and it's essentially storing references to these anonymous functions, and it doesn't yet know which one's going to run. It takes all variables that are referenced within them from the outer scope, and it stores those in its lexical context. So even though this is the one that gets returned and used, it's still storing a reference to this in your lexical scope, so this can't be cleaned up by the garbage collector. So essentially the lesson is generally only one closure per function. If you're going to declare a function inside of a function, only do one, or be aware of that. If you were to, for example, set something to null before you return this function, that would also allow it to be cleaned up. Things like that. But it's just something you have to watch out for because it's a sneaky memory leak that you wouldn't be looking for. So, yeah.
Also, I believe if you hoist one variable from that outer scope, all the variables in the outer scope are hoisted, I believe.
What do you mean?
So if you had a closure inside of your main function there, and inside that main function you had a bunch of variables, and you hoist one of those, use one of those variables inside of the inner closure, I believe all the variables in that outer.
Well, the V8 engine, and I know this is because I've been following the bug tracker on it, but the V8 engine will actually be smart. If you have a single closure, even though technically the context would have references to those, it's actually going to clean them up because it knows that your function isn't referencing them. However, if you use something like with or eval, that destroys all optimizations. The compiler won't make any assumptions, and it's going to store everything. So you'll have memory leaks galore. Don't use eval ever. And then just be careful. If you're declaring multiple closures, also, if this closure is short-lived, if it's not going to be around very long, it's going to get called soon, and then it's going away, you're not storing references to it, it really doesn't matter that much. Even though there's technically something being held onto that can't be cleaned up, it'll be cleaned up when this goes away. So if it's a short-lived thing, then it's no big deal. But if you're storing this function around for a while, then you have to watch out because you are holding on to this variable that you wouldn't think you are. So you just have to be aware of, memory leaks like that. Like I said, the lesson is basically either one closure per scope, short-lived closures, or use the same variables in all your closures. So anyway, that basically covers the major gotchas I could think of. There's a whole bunch of references here. I'll share these slides, but there's a bunch of references to really helpful things you can look at if you're interested. This here is a prototype workshop. You can go through if you're still struggling to understand prototype. It's a series of different exercises you can do that'll help you understand it. And then the rest of this just talks about all the stuff I covered, so you can reference some of the material. So yeah, I'll send this around, and hopefully that helps. Any questions?
You want to email the slides?
Yeah. Yep. I'll send this out.
Any questions? Thanks, Justin.
Good
Good job. So we'll do this next Wednesday, the next 3 Wednesdays.